So this is my demonstration. Water got dispensed. Let's check the OLED display. We can see that it's 4.18 volts before and the pump was on, so that's good. 22.7 degrees. And then this is the graph that got created. And at the bottom we can see like our history and stuff. So as you can see, it's off and it's reading 4.08 volts. The pump is not on. And as you can see, it got updated right there. It got updated on our graph, and that's how it works. For learning outcome 1, I created unit tests with the help of using the JUnit framework, and I tested the value conversions for soil moisture from a 10-bit value to volts and temperature, as well as from a 10-bit value to degrees Celsius. I also tested if the emergency stop functioned as intended to. For learning outcome 2, I went from having one long unorganized class to having multiple distinct classes. I also implemented the process of encapsulation by data hiding my private variables for specific uses. For learning outcome 3, I used two APIs, which are Formata4j in order to communicate with the Arduino Grove board and the Princeton Standard Library in order to make graphs for the soil moisture voltage values, which were read and converted from the sensor. For learning outcome 4, I decided to use an array list to store soil moisture voltage values, in which case each element within it is typed double and gets printed out to the main console for the user to see. For learning outcome 5, I developed an event-driven state machine for my push button, so when it gets pressed, it triggers an emergency stop to the entire system by manually turning off the pump and updating the OLED display to a shutdown message. And lastly, for learning outcome 6, an error that I encountered was that my water pump was dispensing too much water from my plant. So to help fix this, I added a delay so that the water pump consistently provides the correct amount of water that's necessary for the plant.